off with a quick introduction to AI agents, right? The idea is that yes, for many of you, if you're just new to agents, I want to set the context for it and give you an overview of what agents are, how they generally work, and how you could kind of architect them. We'll do that before we actually get into the next session, which is going to go a little bit deeper into the code part of it. Yeah. So, what are Gen AI agents, right? The idea of the agents is these are autonomous goal-seeking systems. These are the two keywords. One, you give it a goal. You don't actually tell it what to do. You just give it a goal, and then you allow it to figure out on its own, right? And that is the autonomous part of it. So this is very different from your traditional automation. Like if you look at the traditional automation, it was very much rule-based. You're saying that I'm going to give out all the rules. These are how different situations are going to occur, and this is how I want you to react in each of the situations. And it was this complex workflow of trying to capture the entire space. But while that was helpful, it's always hard to figure out edge cases in such situations. User behavior is hard to predict. So in all of those kind of situations, the way Gen AI works is actually being much more useful. So the idea is that you have these systems, and of course all of these systems are LLM based. You can give it tools, you can give it memory, you can give it external data, you can give it access to the external world so that it can take a lot more actions on your behalf, right? The key thing with agents is that they follow a sense, think, act kind of a pattern, right? Sense is nothing but you're taking input. You're taking input from the world, you're taking input from the user, you're getting new data to work with. Think is where you're taking all of that information and processing it and trying to come up with the best way to do this. It's the reasoning part of the LLM, right? And finally, act, right? Based on what you have seen, based on what you have processed, you come up with an action plan and then start to execute that action plan. And this happens multiple times. So, it loops continuously until it is able to figure out what is the best plan and then takes action on it. And while taking the action, if it figures out that, okay, something is off or it is not possible to take this particular action, it again goes back into the loop to figure out a new plan of action. So for example, some simple examples, if you want to plan a trip, you can ask an agent to do it for you. It will do some research on the place, it will prepare the itinerary, it will look at what is the budget that you have for this and how can that budget be split up. It will also do your booking of hotels, flights, restaurant reservations, all of those kind of things it can do. Or if you're looking at more of a B2B kind of a use case, it'll be looking at, let's say, sales, right? If you'll ask it to go to, let's say, LinkedIn and find a bunch of different leads from that. You get the leads, you qualify the leads saying that I only want to speak to people who are the CTOs of the company because they are the ones who are going to buy from me. And then you can draft personalized emails for each of them, send out those emails, have that communication going, and finally negotiate and even close the deal. So these are the kind of some simple use cases, but literally you can apply agents to anything, right? Any use case. So by the way, this is an image that I asked Gemini to create about what an agent would look like, right? And it came up with this, and I didn't quite like it. So I said, what does an agent look like if it is not a human or a humanoid robot, right? And then this is what it came up with. I don't know why. I don't know. Maybe it knows something that we don't know. It has all of the world's information. But this was the first thing it prompted, and it's the only thing it said about agents. Okay. Now, let's look at the building blocks of a Gen AI agent, right? At the core of all of these, the brain behind all of these agents is an LLM. So, typically you can either give it like a generic LLM like a GPT-4, GPT-4 whatever it is. You can give it a model that you have fine-tuned and trained. You can give it a reasoning model. So you can pretty much give it any kind of large language model, which will then act as the central processor for all of this. Now, around that central part, you have basically an interface that takes the input. Typically, this is input from the user. It might be text, it might be voice, it might be video, but it could also be anything else. It could be sensors, it could be a camera, it could be anything else that is actually sending information, maybe like from a robot, from IoT, any of these things. That information comes to an orchestration layer. Orchestration layer is nothing but manager, right? It looks at the goal, it looks at the input, and then it says, this is how I want to attack this, right? First, we'll come up with a plan, and it gives it to the planning module. The planning module, of course, all of these use the LLM. The planning module goes through it and tries to reason out, saying that, okay, this is what I need to do. What are the different steps that I need to think through or act on? Once it has that idea, it then goes and gives it to the action module, and the action module takes those necessary steps. And to be able to take those steps, it does something. It uses something called tools, right? And we'll talk a little bit more in detail about the tools. But this is largely how it works, right? And this is how a single agent would look like. Tools part is important. Actually, tools is what makes the agent so powerful, right? It's giving the LLM, which is really good at thinking and really good at coming up with text. You're suddenly giving it an ability to interface with the real world or the outside world. Now, the types of tools, you can have different things. So, for example, you can just have a function like a Python function, which does a very, very specific task. You give that to the agent and say, execute this task whenever it is required. Execute this function whenever it is required. Take, for example, you're a bank and you have a customer service bot, which basically tells what is the interest rate for a fixed deposit. Now, a user comes to the chatbot and says, if I put 1 lakh rupees for 15 days, how much interest will I get? Now, it's very hard. We've seen that you just ask LLMs math questions, they might not necessarily get it correct. It might not do it consistently. And especially when it becomes something related to finance, health, all of that, you cannot afford to have mistakes there. So what you can do, you can actually write a small Python function that once the LLM has got that input of, okay, 1 lakh for 15 days, you can extract those details, give it to the function, just do a function call the way that you call any other function with those parameters. And then the function will look at, okay, right now the current offers that are going on with the current interest rate, for 15 days, 1 lakh rupees would generate this much interest. And then it will give that value back to the LLM, right, or back to the agent. So that function becomes a tool that the agent has used to very reliably calculate what is the interest that someone can get for a certain input and duration. That will then be taken by the agent, and the English is put around it and say that, hey, I've checked it. You'll be getting about this much money by the end of 15 days. But would you be interested in knowing how much you can make if you put it for 30 days? And then so it gets the conversation back going. So the LLM is really good at the conversation in the English part of it. Maybe not so good at the mathematics part of it. So you can actually just give that part to a function, right? Similarly, APIs. If I have an agent that is going to do a ticket booking, now that, let's say, that has to interface with Book My Show to actually go ahead and book a cinema ticket. That can be done through APIs, right? Because then you have inventory, you have to take care of the tickets, you have to take care of payment, you have to do all of that stuff. That could happen through the APIs. Plugins, it gives you, these are already things that are working, these are already tools that it can use very easily. It's a higher level of abstraction, but basically for form filling, web browsing, all of those kind of things. You can give LLMs access to databases, right? Especially for large enterprises, they have so much data already in the database. And now these agents can get access to it in a nice, safe, controlled manner to be able to do whatever work that, that they've, the goal that they've set to achieve. Similarly, file systems and sensors and actuators. So sensors are basically, it could be temperature, it could be pressure sensor, it could be environmental sensors. Actuators are things like switches, motors, knobs, dials, all of these kind of things. So how do you interface with the real world either through IoT or through robotics? That can also be done, because at the end of the day, that also becomes a tool. And in some sense, other agents and humans, right? So this is basically what what tools are about, and this is what gives agents a superpower. Now, typically, what happens is you will have a single agent can do a lot of things, but it's probably good for simple tasks. As the tasks become more complex, you don't want to have a single agent that is going to do all of the things. You would rather want multiple agents that will interact with each other and do the tasks together, right? And that is where the multi-agent system paradigm has come in. It is actually a pretty popular paradigm now, and in fact, most of the agentic systems that we use today are in some sense multi-agentic. So we take that example of trip planning, right? So a trip planning agent essentially will actually need multiple types of agents, each which are very good at doing one specific activity. right? So we'll have our orchestration agent, which is the manager. We will have a research agent that looks at the destination and does its planning. We have a budget allocation agent, weather forecast agent. Then you have, with taking all of this information, maybe you can have an itinerary planning agent, right? And then like that, it has a bunch of things. Finally, it'll come down to the activity side of agents, which is book the flight ticket, book the hotel, restaurant reservation, all of that. So I'll show you, you won't be able to see this, but I'll just help you get the intuition for this. It's a flow chart of how things would actually go if you give it one query and said that book, can you book a vacation for 4 people, for a family of 4 people to Goa next week with a budget of 1 lakh, right? So if you give that, basically what is happening is user input comes in, it goes to the orchestration agent. By the way, this is one hierarchy or one structure that we can talk about. There are multiple other ways that the same thing could be done. But let's talk about this one, right? So you have the orchestration agent. What that will do is it will figure out that, okay, first I need to do all the planning. Now, actually, everything on this part of the board is like planning, everything on that part is kind of the execution, right? So first what it does, it takes those requirements and it says, let me run 3 different agents in parallel. First one being destination research agent. Let it go do the research. Tell me about Goa, which are the places to go to, what are the things to do there. There's a budget allocation agent which takes the money of 1 lakh and says, okay, this much for flights, this much for hotel, this much for F&B, this much for activities. And then a weather forecast agent which will look at it and say that, okay, Goa is going to be a little hot at this point of time, so we will plan accordingly. All of that information then goes back to the orchestration agent. That looks at all of those outputs and then gives it to the itinerary planning agent and says, look, for with this kind of budget allocation and with all of this information about what all you can do in Goa, plan out an itinerary for 5 days. And it will do that. It will create a detailed itinerary which will then say that you can go to water sports, you can go to different sightseeing places, all of those things. That is then going to, let's say, an activity planning agent, which will create a detailed plan saying, okay, if it's water sports, you can do these. Now that it sends it back again to the orchestration agent. Now that it has all of this information, it says time to start booking, right? So it again sends it. So until now, this was sequential, right? It finished the first set. Once it has an idea of what it wants to do, it then goes to the second set and says, start booking, but do all of that in parallel. So it will call the flight booking agent, it will call the activity booking agent, hotel booking agent, and reservation agent all at the same time. And all of them do their work of planning it and they will try and book it. If everything goes well, it all comes back, goes to the orchestration agent, which puts it all together, creates the final trip, and sends it to the user and says, these are all the things that you will do, and these are all your tickets for it. Have a good trip. But what if things go wrong, right? If something goes wrong, let's say the flight reservation is happening here, flight tickets have become too expensive. Now it is not fitting in the budget. So the flight booking agent will go back to the orchestration agent and say, not able to get a flight within the budget that you asked for. Please suggest next steps. Orchestration agent then takes it to the budget allocation agent and says, we need to relook at the budget. And the budget allocation agent will then say, okay, flight ticket have gone up by overall 15,000. There was one activity that was 15,000. We're going to have to drop that, and it will then create a new activity. It will send it to orchestration agent to get a new activity plan, as well as to the flight booking agent to say you can go ahead and book the flight tickets now, right? And this can go on multiple times until you have a plan that kind of satisfies all of the criteria and you can book it. Now so this is basically a hierarchical model, right, where there is one orchestration agent which is doing all of the communication and all of the messaging and the management of the things. But it is kind of inefficient because imagine the amount of time that gets wasted each time it has to go back and forth. Why can't the flight booking agent directly talk to the budget allocation agent? If it says that, look, not enough budget for the flights, it should actually go to budget allocation agent directly and get a new budget, right? Similarly, the budget allocation agent should then directly talk to the activity booking agent and say that, okay, cancel this activity, we don't have budget for it, and so on. So that is actually more of a flat structure where agents talk to each other and they're able to kind of manage things by themselves. The reality is both of these architectures are possible and are quite often used also. And so those are the two things that I wanted to show you here. One is you can do things in parallel and sequence and a combination of those. And secondly, you can do it either hierarchically or flat or again a combination. So strictly speaking, we have used a hybrid here, right? There is an orchestration agent which is doing a lot of the stuff, but the activity booking agent is talking to the activity planning agent to actually get the recommendations. And similarly, they're talking to the other agents like detailed itinerary, all of those. So,
multi-agent system architecture is for scalability, or what is the reason to have such a system?
So it's basically what happens is if you have agents that are very good at one specific task, that one part can keep on improving, right? So tomorrow, let's say the flight booking agent. First, you had only written it in such a way that it books through Make My Trip. But then tomorrow, you want to extend it so that it can also book through Clear Trip, and so on and so forth, right? So it becomes modularized. You can keep on improving that one agent. That is one of the reasons. It's basically software principles. But the other thing also is that when you have multiple agents rather than one agent, you can start to do things in parallel, right? Otherwise, everything becomes sequential. Step by step, the agent will be going. Now this,
yeah. If you have such a multi-agent complex system, the communication, if it is not standardized, we will get locked in.
Yes.
Whatever you are going to do.
Yes.
So that's a risky part, right? Even just for past 1 year only, we are talking about MCP, AP, and all.
Correct.
So
correct.
that's not mature. Is it not risky to adopt this architecture now?
No, you can still do it, because what happens is even where there are, when it goes into an infinite loop, the orchestration agent can actually say that, look, time out. This has gone on for too long. Stop it. Let's figure out something else, right?
For example, booking and budget agent, right?
Yeah.
The communication between two
is
not standardized right now. So if you are going to take your own method for communication, that will get locked in, right?
So in some sense,
agent inter-agent communication protocols are getting defined for past 1 year only.
Yes.
So it's not mature. Adapting this kind of system and adapting proprietary interface and doing all this multi-agent complex system is not risky enough at this stage.
Not so much.
Good for future, not
good. So even now, within a particular framework, the communication is pretty okay. There's not that much problem. So let's say that you're just using Crew AI. Between all of these agents, the communication is already sorted because they all follow the same protocol. The challenge right now is if one agentic system has to talk to another agentic system, there the communication is not standardized, which is why all of the MCP and A2A and all that are becoming important now.
So you're saying the framework or the platform like Crew AI and this agent builders automatically take care of the interfaces between agent. And in future, if you want to change it or do something, it will do it yourself.
Yeah, I mean, see, your travel booking agent might interface with the company's, HR agent, right? The HR agent will call the travel booking agentic system to say that plan an offsite for 20 people to go to Goa, right? Now, it might be that the HR system was built using LangGraph and this was built using Crew AI. That communication is not yet standardized, but within Crew AI and within LangGraph, the communication is standardized. So that's currently where it's at, but it's a good point. It is definitely going to get resolved, shortly, and that's why the world is kind of moving towards those multi-agent communication protocols. Okay, so I think I won't go into details here, but these are some of the popular kind of agentic frameworks that are there now. Of course, we do have Lyzr also here, and you will hear directly from the head of engineering at Lyzr. But for now, these are some of the things that just came up. You can take a look at some of these things. One thing that you should keep in mind is that because everything here is an LLM call at the core of it, right? Every activity that the agent does requires some thinking, some action to be taken. And so it becomes a function of the LLM that you're using and what is their pricing, right? So if you're going to use an open source LLM or your own LLM, then yes, you have to think about the infrastructure or the hosting cost. Otherwise, if you're going to use something like a ChatGPT, you might even have to just think about how much is each of these things going to cost me, how many tokens am I sending, how many tokens am I getting back. So I stop it there. I'm not going to go into detail here, but I will anyway share the
Serious about a career in AI? Follow Deep Tech Stars on your favorite social media platform.